It is my great pleasure to introduce our esteemed speaker for the today's session, Dr. Ranjeet Ranjan Jha. Dr. Jha is currently serving as an assistant professor in the mathematics department at the prestigious Indian Institute of Technology, Patna. His academic and professional journey is both inspiring and impactful. Dr. Jha earned his PhD in the Computer Science and Engineering from the Indian Institute of Technology, Mandi, in October 2023. His doctoral research focused on the medical image analysis, employing cutting edge deep learning methodologies, a field that is informing healthcare and diagnostics techniques globally. Prior to joining IIT Patna, Dr. Jha gained a valuable industry experience as a data scientist at Sahaj AI Software Private Limited in Bangalore, where he has worked on innovative AI solutions. In addition to his PhD, Dr. Jha holds a master's degree in the computer science and engineering from the National Institute of Technology, Goa. His research interests span across medical imaging, deep learning, biometrics, computer vision, and other closely related areas, making him an expert in fields that are shaping the future of technology and medicine. Today, we are fortunate to have him to share his deep insights into the world of deep learning applications in the medical imaging. We are confident that his expertise and experience will bring tremendous value to all of us. Please join me in welcoming Dr. Ranjeet Ranjan Jha to this session.
Yeah, thank you very much for such a nice introduction. So, I'll be talking only overview of deep learning. So, it's not like the problem related to my research, but it's like general problem that I'm going to discuss. And what are the current trend that is going on nowadays. So, I'll be discussing those like all of the things, uh, whatever things are like new, or you can say the current trend. So before going to like any application, first let's understand like what is deep learning. Okay, maybe this could be repetitive, but for the sake of completeness, I'll be explaining this part also. So this the whole area that is called artificial intelligence, and it's not new. It's like maybe several, it's like we can say maybe more than 50 years uh, back technology. Okay, so but in AI, many things have been explored, and if you see nowadays we have in AI we have computer vision and machine learning. So AI is like one bigger circle, and in that circle, we have so many things like computer vision, then machine learning, and then there is overlap between your computer vision and machine learning. So computer vision is like related to vision problem, like whatever problem you generally see, image, video, speech. So those are related to vision problem, and we have to somehow solve that problem. And for that, we have machine learning. So you could use some of the algorithm from the machine learning for the computer vision problem. Okay. And then we have deep learning. So deep learning is again, this is also, we can say this not totally new area. It's like part of your machine learning. And this is one that's a sub part of the machine learning. And again, there is, we can see there's, again here, there is the overlap between your computer vision and the deep learning. You can see that. So it means you can solve several problems of the computer vision using your deep learning techniques. So previously you're having machine learning, traditional machine learning, And nowadays you have deep learning, which is which is having better algorithms compared to traditional machine learning. And you can take the advantage of these algorithms and you could solve multiple problems of the computer vision. Okay. Okay, so in totality, if you see this whole things, whatever we discuss is part of your AI. Okay. So you cannot say like this is separate from the AI. It's part of your AI. So whatever problems we are solving and we are using some of the we can say training thing. If we are if the training is involved, or we can say uh, some smartness, because either you can use like rule-based techniques or like all the previous techniques where there is no any smart algorithm. It's like just we can say manual algorithm. But if you are putting some smartness there, then that will be seen as a that will be seen as a part of your AI. So before, yeah, so we'll talk. I will talk about some of the algorithms which are very popular nowadays, and it would be used for multiple applications. Before that, first understand the very simple problem that we generally see in the computer vision, and this is the simplest problem, or you can say the core task in computer vision. So given the, you can see here, we have given the image. This is the image that we have given. And your goal is to give the class level for this image. Okay. Now for the humans, it would be easy because our training has been done in that way so that we can understand the visual stuff. So if I give you this image and if I ask you what is the class of this image, you can easily say this is cat. But for the computer, because your computer cannot see visual stuff, for your computer, you have to do something. You cannot put this thing as it is because you know that computer can only understand, we can say, numerical values. And this is not numerical, this is visual stuff. So first thing is, if I want to solve problem, if I want to solve this, because this is one problem, this is image classification problem. And we can solve this thing because we have been trained in that way. But for the computer, if you want this problem to be solved by the computer, then first you have to convert this thing into the computer language. That is the first task, because you cannot give this thing as it is. So you have to convert this thing into computer language. And there's pixel is involved. Then maybe you might be knowing about grayscale RGB image. So those are the we can say the way by which we can represent our image into numerical values. Okay. And once you are done with that, then you could be giving this image to the your uh, neural network or deep learning network. It could be anything, even machine learning algorithm. And then your deep learning or machine learning algorithm will be trained based on this. Because you have to train the network, you have to train the model, because our model has been also trained. So if you see the child, so he will start learning by seeing the environment, by seeing the surrounding. So once child suppose birth, so after that he will see so many things. He will try to observe, he will try, so he will also try to walk, he will try to uh, crawl, so he will try to do so many things. and slowly his or her learning will be happen. So in our mind, we have neural network, and our neural network is also being trained based on the your based on the surrounding data or based on the environment, whatever we are seeing. So in the similar way, your your deep learning model or have machine learning models have to train, and it needs a lot of data. It needs a lot of surrounding stuff. Okay, so we can train the network, we can train the model, we can train the deep learning model, but we need data, we need samples, and you have to convert your visual stuff into the numerical values. Then only you can train your model. Okay, you can see here the goal is, suppose you have two class classification. So suppose you have to solve the two class classification problem. For example, if you have cat and dog, two classes, we have cat and dog. Now the goal is, so whatever algorithm you are training, whatever algorithm you are using, either machine learning or deep learning, the main purpose is to find one boundary, one boundary which will differentiate between two classes. So suppose you have two classes, cat and dog, then somehow it will find this boundary which will divide these two classes into two parts. So now if you see here, this is one class. So here each value, you can see each point that represents one image of that class. Okay, so suppose for example this is cat, then each point is one image, and the class of each point is cat. Okay, similarly for the other class. So we have to somehow find this boundary. Okay, and it could be seen as a India-Pakistan border. So it's like this part we have all the Pakistanis people, and this side we have all the Indian people. Okay, and we have one border which is dividing these two parts. So we have to somehow find this thing. We also do we also find this type of stuff using our neural network. So in our mind, the similar things happen. So here also we try to find the boundary. We try to find the differentiating property. Based on that, you can differentiate between different objects, different images, different classes. So in the similar way, machine also has to understand, or deep learning also has to understand this boundary, or it has to find this boundary. If it is able to find this boundary, then our goal purpose is fulfilled. Then just use this boundary, okay? And you can say, given the sample, you can say what is the class of that sample. So if it is lying this side, it means this is cat. If it is lying this side, it means this is dog. So there are so many things involved in deep learning or in machine learning also. So many times I'm also taking this name machine learning because machine learning is again the bigger view of this deep learning. So your deep learning is part of your machine learning. Okay. So that's why most of the time I consider I also take this name. Okay. Okay. So in the deep learning, we have so many things because if you have given the model, you have to somehow train. So one model can be seen as a one child, and you have to train that child. Okay. So what should be the way by which we can train? So you can just think this thing as a with respect to our neural network. So we see the images, we see the surrounding, we see the other people, and then we learn. Here, in this case, one model, one algorithm, or one, maybe we can say as a network of deep learning, or one model we can say, but model, once we have trained thing, then we generally say model. But yes, vaguely we can say model. So if we have given this box and this is child, this does not know anything. No, and now I have to train this thing so that after some time it will try to give proper result or proper output. And it depends on the problem, whatever problem we are solving. So suppose you are solving the classification problem, then this whole setup, this box should give accurate classification, accurate classes once it is being trained. At the starting, it will give you a random thing because it does not know anything, just like child. So, but once it is being trained, then it will be giving you proper output, proper result, expected result. Okay. So many things are involved here. One thing is that we have to show the image, and then it will try to see the image, and every time it will get something. So if this is model, if you give the image, this will image, it will be given to this, and this model will give you output. Suppose in this case, suppose you are taking the classification task, then it will give you class. So maybe we are giving this image, it will give you, suppose this image belongs to something, maybe cat, but your model is giving you dog. So it means this setup is not working properly. Why? Because it has not been trained. So we have to train. So how to train? So for training, whatever output I'm getting, I have to find how far I am from the actual output. So you know that this is dog, you are getting dog as an output, but in actuality, this is not dog. Your model should give you cat, but your model is not giving you cat. So then you have to find the difference between your predicted class and the actual class. And then that will be like your unhappiness. Because since your result is not good, so you are unhappy. So you have to find the unhappiness. And then you have to quantify that unhappiness. Quantify means you have to find the difference. And that difference should be minimized. And for that, there are many algorithms which are being used. Algorithm is for optimizing this stuff is your optimization, because you are solving the optimization problem. So this is like one crucial part. There are several other things also involved there, like finding the gradient, and many things are there. I will not talk about those things. But in simplicity, in general, we can say that we have to somehow optimize this problem, or in other words, you can say we have to minimize the unhappiness. And goal is to reach to the happy place. Okay. So optimizer will help you. So you have optimizers, we have so many algorithms which will help you to reach to the happy condition. And then there is regularization also. So I'm not going to talk about. This is again the part of this deep learning training. So sometimes your model get overfitted. It's just like your model is memorizing all the things, but you don't want that thing. You want one boundary. So if it is memorizing, if your model is memorizing the things, then it is not general model. Just take the example of, just take the real life example. Suppose one student is preparing for the exam. Okay, maybe for the IIT G exam, G advanced exam, or maybe at the same time he'll be also preparing for the board exam. So if that student is memorizing all the things and he's not thinking in a logical way, he's not uh, uh, like solving the problem in a proper way. It means just he's memorizing all the stuff. So if he's memorizing all the stuff, he may get good marks in board exam, because your board exam will give you questions from your guest paper or books. So if you have memorized all the questions and all the answers of the questions, then you can get good marks in the board exam. But if you give the IIT exam, then you will be failed, because in IIT exam you have to use your mind. It's not like if your question will not come directly. So the first condition where you have just memorized the stuff, that is called overfitted model, because it's just memorizing the thing. It's not learning the boundary. We need boundary. We don't want overfitted model. Okay. So if the model is memorizing the things, that is not accepted in the case of IIT exam. Okay. So in the deep learning also, so if you have overfitted model, this is not accepted. So you will not accept overfitted model, because this type of model will fail in the case of new images. So suppose new images are coming, or if slightly different images are coming, this model will fail. It will give you wrong classes. So in that case, so overfitting case, we don't want overfitting case. We don't want a model which is just memorizing the samples or data. We want model which will be generalized model. And for that, your regularization will help you. Okay. So these are like very uh, long topic. So it again takes a lot of time uh, to teach these things. But I have just given you the overview of this. So if you see here, this is a neural network, and that is, we can say, the first part of your the deep learning. You can say deep learning stuff. So it's like your deep learning it starts from the neural network, and this is also called fully connected network, because here, if you see, every output is connected to each input. So that's why this is also called fully connected. And it's again a very big topic. So I'll just put here for the sake of completeness. So this is the first architecture. Maybe you'll be getting this type of stuff in this workshop, maybe in later uh, sessions. So this type of stuff is called neural network, and also called fully connected, and where we have inputs, and then you can solve the different types of problem like classification problem. Many all type of problem can be solved using this neural network. Okay, so if I want to solve some problem, so first thing is that if I want to do something, first I should be having some task or I should be having some problems on which I'll be working. And for that problem, I also should be having data because data is like samples, collection of samples. So if you are solving the classification problem, you should be having, uh, suppose you are solving the image classification problem, you should be having several images along with class labels so that you will be using those information, those samples for training the model. Okay, so you should be having the problem statement, and then for that problem statement, we need data. And once we have these two things, then we need models. So the first model that I have shown you, the first model of deep learning is neural network, or also called fully connected. And then there are so many networks which can be used as a model for solving the particular problem. So till now, I have just talked about classification problem, like given the image, and we have to solve the classification problem. We have to give the class level. Again, there are so many challenges when we are solving the classification problem because suppose take the example of images. So in the image, we could be having so much variations. For example, uh, uh, there could be like the images from different viewpoints. Maybe you could be having images from different scales. There could be like clutter in the image, or maybe there could be noises in the image, blurriness in the image. So there are so many challenges. But nowadays, like we have very good model, and that model even it can work in in that type of for that type of issues. So if there is some variation in the image, still this the existing model can give you. So that is like one classification problem. Given the image, you have to give the class label. Now there are several other problems also. For example, if you see here, this is semantic segmentation problem. So in the first case, you had given the image, and your goal was to get the class, just one value for that. Suppose this is cat. Now in the second part, I have to segment the image. I have to somehow cluster the object in the given image. So if you see here in this image, we have so many things. For example, this part is your sky. Then uh, there is this part is tree. Then we have grass, and then we have cat. So your model should give the segmentation of each type of object. So it's not single class classification problem. It's like you have to label each and every point of this image. And that point is called pixel in technical word. So you have to classify each pixel. So which class this pixel belongs to. So if you see here, so we have given one color for the one type of classes, other color for the other type of classes. This is for third type of classes, this is for the fourth type. So in the same image, we have four different classes. And each pixel is assigned the corresponding class, the appropriate class. So this is called semantic segmentation. And then we have object detection also. So object detection is, again, this is very, there is like, uh, this is also very important problem. And you may find this type of problem at many places. For example, if you have a self-driving car, so and that is like running on the road. Now, in self-driving car should understand all of the things, whatever going uh, on the road. For example, pedestrian is walking on the road, or uh, maybe some stones are on the road. So your car should understand. Your car should understand the class, like what is the class of the object which is there on the road, and along with the distance, like what is the location of the object, so that it will take the decision. So should I stop or not to stop? Because if suppose pedestrian is there, suppose person is there on the road, then your car should stop. Otherwise, it will hit the person. So in that case, your object detection will help you. So it will give you the location, and then you can just find then like all the processing will be done in the car, and then it will decide like whether I should stop or not. Then there is another problem that is called instance segmentation. So it's like again, just uh, so you can see like in object detection, we are getting the bounding box along the object. So this is like position of the object, and it's also giving you the class level. So what is the class of this object? So we are getting the location along with the class. Now, instance segmentation is just one ahead. It's like maybe we can say like improvement of this object detection. So in this case, we are if you see the object detection, we are not getting the exact we can say exact structure of this dog. It's just like rough approximation of this dog. But in this case, we are getting exact approximation of this because giving you the contour shape, just touching the edge of the dog or edge of the object. Okay. So this is called instance segmentation, and there is again application of this instance segmentation. For example, if you have suppose you are solving the medical imaging problem. So suppose someone has like maybe you might be knowing about tumor segmentation. So suppose somebody there's tumor in the brain, and you just take the image of like MRI or CT scan, it could be anything, and you have to like we have to somehow segment, or we can say localize the uh, tumor by seeing the image. So in the image, you will be localizing the tumor. And once it is being done, then surgeon will just it, he will do the surgery, and he will do the surgery in such a way so that uh, except your tumor, other parts should not be distorted. Other parts should not be destroyed. Because suppose because brain is your crucial part. So if he's inserting something in your brain and just taking out the tumor from the brain, so in that process, this whole process may destroy other tissue of the brain. And if that is happening, then you are in trouble. Because if you are destroying some part of your tissue, then it will affect the body part. Because you know that the whole body is controlled by your brain. And each part of the brain is responsible for the for the course for the particular part of the body. So if you are destroying one part, your control over the particular part of the body will go, and that we don't want. So that's why this is like detecting, segmenting the tumor in a very appropriate, in a very accurate way is must. And this type of, again, deep learning algorithm can solve this problem. Okay, it can give you a decent, good performance uh, in this particular case, and then doctor can decide like how to insert the needle to the brain so that I will not disturb other tissues. So again, this is the one of the applications of the instance segmentation. Then till now we have only talked about the imaging stuff, but your deep learning can also solve other type of problem, like video related problem. So if you see here, this is the video. It's not image, it's video of frame sequence of frames. And the task is to classify this video. So what is happening inside the video that you have to say. So by seeing this video, your model will give you the class, like what is happening inside the video. So maybe you can say like this person is running or maybe jumping. So these are the classes. So take the video and give me the class, like what is happening in that inside the video. So this is one type of problem that can be solved using your deep learning. Then you could be having multi-modal video understanding also. So in the first case, I'm also it's just like just sequence of frames that I have. So only imaging or images are involved here. But in the second task, if you see here carefully, this person is doing something. So images are there, like we're getting the images, multiple frames, along with sound is also being generated because one, when he's doing something, the sound is also being generated. So we have two modality. One is image and another one is your, we can say, song. So this is a mixture of two modality, and your model has to, your deep learning model will understand like what is happening here, and it could give you maybe one sentence for this, like this person is doing this thing. Then another task could be visualization and understanding. So most of the time when we use deep learning, we generally see deep learning as a black box because we don't know like what is happening there inside the box. We generally just arrange the layers, arrange the different components, and then our job is done. Now we'll be only seeing the loss function and images. So we don't bother about the inside part, like what is happening there. And that's why most of the people say this thing as a black box. But even in that black box, you can go there. We can find the intermediate result, and we can also try to see like what network is or what particular layer is trying to see. And this is again one type of maybe we can say one area of research. So where people are trying to visualize, understand the the different parts of the or different components of the black box. Okay. So yes, if you see here in this part, like this is just one example, and they have just taken one uh, intermediate result from the deep learning networks, and then what they observed that in this part it's giving higher values. It means the focus of the model is on this part. Like attention, more attention has been given on this part. And that is true. That is correct. Because if we are solving the classification problem, then this only this part is crucial for me. Because our goal is to give the class level for this image. And the class level for this image is cat. And if you see the only this part belongs to the cat. So in that way, we can also try to understand, you can also try to get the intermediate understanding, like how the things are going on. So you should not take this deep learning as a black box. You can just take the things from the intermediate layers and then you can try like what is happening there. This is so models, if you consider model, then first is your neural network, fully connected network. And then, and that is also called multi-layer perceptron. So there are many names for this for the same stuff. So you can use the first model, your neural network, multi-layer perceptron, but it has few limitations. So I will not talk about those limitations, but it has some limitation. So that's why several other models also came into the picture. And other model is like the your convolution neural network. This is again second model, CNN model, which will take the image and it will also give you the like it will also solve your problem. But here it has tried to somehow overcome the limitation of the multi-layer perceptron, or you can say the first model. And again, you can solve the almost all type of problems what you were solving using your multi-layer perceptron. But this CNN will give you some advantage. This is also called, in short, you can also say this thing as a CNN. So CNN will solve it will give you some advantages over the multi-layer perceptron with respect to accuracy and the uh, memory requirement. So mainly this multi-layer perceptron and CNN have been built for the for the image type of stuff, for solving the problem where there is image or video. Okay, so mostly uh, it was for the for the imaging stuff, but we also know that one very interesting area is NLP, natural language processing, like related to your text. So if you have given the text, then how to solve several type of problems, like classification problem, sentiment analysis. So it could be like there could be many type of problems, but those problems are related to text. Okay. So again, for that, again, one separate type of uh, uh, family, neural network family came into the picture, and that is called recurrent neural network. So this is for the text. So if you want to solve the text problem, then you can use RNN. But this RNN is old. Okay, this came around, it's very old approach. It's now maybe 10 years back. It came 10 years back. So, and it has so many, it has given good performance, decent performance, but it had some major limitations also, some major cons also. And due to that, people started to think in a different direction, so that all the whatever limitations are there in RNN, that can be overcome. And then this transformer came into the picture. This is also called attention mechanism. So transformer came around 2017, and the first paper was attention all you need. And initially, it was used for the NLP task, like text-based problems. And it was like that time it was popular for the text-based problem. And uh, but around this came 2017, okay. So but after maybe 2 3 years, people also started to uh, uh, apply this thing for the other type of problem, like can I apply this thing in computer vision, can I apply this thing for the image, can I apply this thing for the video. And then the researchers started to think in that direction. So around 2020, people started to use this thing for the imaging computer vision tasks like image and video. And if you see nowadays, it is being used everywhere. All the problems, maybe most of the problems, whatever we are solving nowadays, at many places, we are using transformer based. Maybe either it could be transformer or it could be variant of the transformer, or maybe it could be a combination of your CNN transformer. Okay. So at many places we are using, researchers are using this transformer networks for solving the problem. Okay. So just see few more applications, and then I will I will uh, I will end the session. Uh, this is again one type of problem that can be solved using deep learning. So you can see here the left image is your real image. It's like the image that has been taken by the camera, and the right image is the cartoon image. So input would be your the this particular image, and this is the cartoon image. And how it's happening? This is being generated by your deep learning. So you can see like this is again it's magic stuff. So it's like uh, the job of the cartoonist is also that will be also in trouble, because now you can just use your model. You can just use the deep learning model and you can make the very nice cartoon image from that. Okay. So that is again, this is called generative modeling, because we are generating this thing from the given input. Again, this is another example of that. So here, this is called Delhi E2, and maybe you can find on internet this thing. It's like it's available on the internet, and you can use this tool uh, for for uh, for getting this type of stuff. So it's just like text to image stuff. So you have to give the text, and it will give you the image. It will generate the image from that. So if you see here, what I'm saying, just giving this command, that teddy bears walking on new AI research underwater with 1990s technology. So this is the input for the neural net, for the deep learning. And our model is giving this image. And you can see, we can see that we are almost getting the aligned image with respect to text. This is just like when suppose I go to my class and I'm saying that you just draw one image on your paper, and I'll just give some instruction like you have to draw in this way, you have to draw the image of cat and like that. Then what you will do, you will just draw the image. So the same thing is happening here. So you are just giving the instruction and your model is giving you the image for that particular instruction. It's very great thing. That is, yes, that is happening. Uh, there you can go from like the first start that I've shown. This is like given the text, the goal is to generate the image. You can also go from your image to text, just like this is also called getting the description of the image. So Delhi you to like you can go in one direction, give the text, get the image. You can also go from the image to the text. So whatever information you have, you just give to the model and it will give you the corresponding result. So if you have a text, give to the model, it will give you image. If you have image, give to the model, it will give you text, like description of the image. So in the both way, you can go. So again, this is called vision model language because we are using both the stuffs, your image along with text. It is very popular nowadays. It is very popular. It's also called the technique that is being used that is called clip. Uh, uh, Again, Delhi 2 example, I've just shown this thing before also, and it's very, you can say, interesting example. Uh, Teddy bears working on a new AI research on the moon in the 1980s, and you can see the similar image it is giving you. So it's like teddy bears are there, then new AI research, and then 9080 technology. That's why these systems are looking like a 1990, 9080 systems. Then in the second, rabbits attending a college seminar on human anatomy, and you can just see it's very comic image, but your model is also able to give you hypothetically image. So this is not, it's like hypothetical text that I'm providing, and your model is giving you the corresponding image. Then a wise cat meditating in the Himalayas searching for the enlightenment. And you can see like you're getting the stuff. Okay. Then we have Delhi E3 also. Again, Delhi is being developed by this has been developed by OpenAI, and OpenAI like they are uh, investing a lot of money on AI research, and every year they are publishing so many papers, so many they are providing so many tools which can be used by the people, by the common people. Uh, One application, one most popular application can be, maybe I will talk that thing after this. So Delhi 3 is like, you can even give the story, the full story of the image. I'm just providing the full story. There are so many things involved here. And your model is giving you the corresponding image from this story. So Delhi E2 was that was only talking about the sentence to image. This is like paragraph to image. So just give one paragraph and it will give you the the appropriate, the proper image for that paragraph. Yes. So GPT, maybe you might be knowing about this thing. So GPT 3.5, that is again by OpenAI. So that is also called Chat GPT. And so Chat GPT is very known thing. So Chat GPT, you can ask any type of questions from the Chat GPT, and it could give you the corresponding answers. Now in GPT-4, so in GPT, that is again, Chat GPT is using GPT-3. So in the GPT-3, uh, uh, you cannot use image. It's just like text to text. So just give the text, it will give you text. But in GPT-4, they have also given the flexibility of using image. So you can give the image and then you can ask the question from the image. So for example, this is the image that I'm giving, and I'm also asking this question, and your model will give you the answer for that. The same thing is happening here. I'm just giving this question and the image, and your model will give you the answer. Okay, so in GPT-4 again, this is advancement of your GPT-3, where we can also provide image. Then there is again one other tool that is called segment anything model. So like previously people used to use a specific model for a specific segmentation problem. But nowadays, like again, this is by segment anything by Meta. So this type of model has given you flexibility by which you can use any type of image and give to this, and it will do the segmentation. So no need to use one specific model that we used to use previously. So SAM is like then there's SAM 2 also there. So it's like SAM 2 is again for video. So this is for the image. Then you can also this thing for use this thing for the video, and then for that we have SAM 2. So these are like sort of miracle things which are happening nowadays. Then you can also play around your video. So for example, I have to edit the video. So previously, how we used to use we used to do, we generally find the video, we take the frames, and then we change the stuffs in the frame, and that was being done manually. So if you want to edit the video, you have to do all the things manually. But again, for that, nowadays you have Sora, which is automated. So it will take the video and it will edit the video. So you give the video, and at the same time, you can also give the text, and it will change the video accordingly based on your text. The same thing you can see here. You are giving the video, and along with this text, and you can see this the you have just edited the same video. So whatever instruction you have given, now you are getting the that type of stuff. So you can also use this thing for the 3D vision. Yes, the whatever we have discussed, those are related to 2D stuff or maybe video stuff. But your deep learning could be also used for the 3D vision. And again, this is again one area of research. These three people are like they are called father of this deep learning. So they got a Turing Award in 2018, and this is like prestigious award in computer science. It's similar to like Nobel Prize in computer science, and so they have done a lot of things. Uh, they have given a lot of things in deep learning, and that's why they call the father of deep learning. So that's all. So I'm done. Anyone has any question you could ask?
Sir, suppose I'm Snehal Moge. Suppose
Mm-hmm.
that we have an X-ray image.
Mm-hmm. Mm-hmm.
We want to use deep learning in that
Mm-hmm.
classify the
Mm-hmm.
X-ray images of knees. X-ray images of knees. So what should be done?
X-ray image of what? Your voice was breaking in between.
Knee X-ray images.
Knee X-ray image. Okay. So, like, what are the classes there? Like, what you want? What
So
is the actual
yeah,
classification problem?
basically I want to detect osteoarthritis. So there are five
Mm-hmm.
levels in that Kelvin and Lawrence
Yes.
level.
Okay, okay.
So
So
how?
yes, yes. So this is sort of classification problem that you want to solve. So for this, first thing is that you need a lot of samples of X-ray, and for each class. So suppose you have 5 classes. So for each class, you should be having sufficient amount of X-ray images. And once you have this thing, then you can just take one type of model from the deep learning, and then you can train that model for this particular task, and you can do this thing. It's not big deal. It can be done, just
So
like simple
in the in the
classification
in the
problems.
in the coming sessions, you'll be teaching how to deploy the model and train it and all.
No, I think other experts are there. They will be teaching.
Okay, sir. Thank you.
Hmm. Thank you.
Hello, am I
Yes,
audible?
yes, please. Yes, yes, you're audible.
Sir, how to tackle the fake video classification?
Hmm. Yes, again, this is yes. In this case also, if you want to solve this thing as a classification problem, then you should be having like we'll be having 2 classes. One is real and one is fake. So for real, we have to collect all like several videos, and that will be there in a one folder. And then you also have to collect videos of fake classes. But in reality, you'll be not getting good amount of videos for the fake classes because this is you can say not a frequent occurring event. So you may be not getting so many videos. So maybe one way is that if you are getting good amount of videos for fake classes, then you can just see this thing as a two-class classification problem. So given the video, I have to give the class level, whether this is fake or real. If you do not have sufficient amount of videos for the fake class, then you may be solving this problem as an anomaly detection because fake is just like the anomaly stuff. So that is again one separate domain. So if you want to learn, then you have to somehow dive into that particular domain.
Okay.
Okay. Any other questions?
Sir, how we can use the attention mechanism in Earth observation data?
Attention mechanism in what data?
Earth observation.
Earth observation data. So uh, you have to see. Actually, I don't know the much about the data. So first you have to uh, somehow
Actually,
project
sir,
your
these are
yes.
images by the SAR and optical kind of images.
Mm-hmm.
The images
Okay,
actually
images.
didn't
So these are
freeze.
only
It is
images only.
yes, sir, but it is taken by the satellites like SAR and Sentinel-1 and etc.
So this will be like high quality images.
Yes.
Mm. So for high quality image, again, uh, uh, how many images you have? Like you have how many classes you have?
Uh, Basically, these images are time based images, sir.
Uh-huh.
So there are actually two kind of images. One is for the actual images that is taken by the cameras, okay, and
Mm-hmm.
another image that is like taken from the satellites. So, like if we are going to classify something on the basis of satellite images, that is the
Mm-hmm.
purpose of things. So, like, can we use the attention mechanism?
Yes,
How?
yes, yes, yes. You can use attention mechanism could be used for the image as well. So like there is VIT, visual image transformer, that is built for the image based classification only. and VIT is again using the attention mechanism. So there are so many models based on attention, and those models could be used for the classification problem. You may find so many models, so many attention-based model for the class for the image classification task.
Okay. Thank you, sir.
Thank you.
Sir, I have one question to you. Hello.
Please, please.
Sir, actually, I am working in the healthcare area. My area is basically in the heart blockages for a particular patient. The thing is that
Mm-hmm.
today, lot of robotic surgery is going on. Now, what question is that
Mm-hmm.
though in the heart area there are so many arteries are available, but some arteries are getting so much blockages, some are the particular percentage of blockages. But when we
Mm-hmm.
supplying this video to the CNN model, I am question is that how much accuracy we can achieve in case for replacing the arteries based on nanotechnology, because a lot of nanotechnology related area they are developing some kind of materials that can be placed in the heart arteries area to remove the blockages arteries and replace that blockages artery with the help of these nanotechnology related material that I yesterday before I see in the internet. But question is that
Mm-hmm.
do you think that CNN model time of accuracy we are reaching for identifying the particular blockages of artery and
Mm-hmm.
replacing the arteries with respect to the accuracy, because obviously everything are under the control of robotic surgery. So where the CNN model providing the output based on the robots will go and replace the particular arteries or remove some kind of things so that it will artery blockages can be bypassed to the another route. But sir, my question is that do you think that this CNN model accuracy is best for this kind of replacing cases?
I cannot say that the CNN model is best, but if you want a best model, you have to have a lot of data because, for example, you are solving this problem where you have to find like what is the percentage of blockage. So you could be having that type of information at great extent, so that you can show those information to the your deep learning model, and then your deep learning model will be trained based on that.
Sir, thing is
And
that
maybe yes, yes, please,
we are
please go ahead.
basically we are, we are basically coronary angiogram reports or videos we can. So suppose we have
Hmm.
the patient suffering from very much problem for the blockages, they come to the hospital immediately. We go to the coronary angiogram for the patient. We receive create so many videos for the blockages area of the heart and then
Hmm.
supplying this total video to the CNN model to receive
Hmm.
find out the accuracy area for replacing the arteries. Do you think that because it is the life risk of the patient, so thing is that
Hmm.
do you think that CNN model accuracy is good for, or we receive good accuracy of the particular CNN model to replacing the particular arteries based on the videos?
Uh, uh, Actually, if you see in this direction, research is still going on. So it's not fully implemented. Okay. So, but this can be seen as a future. So in the future, we would be using deep learning model for this type of stuff. But nowadays, if you see just the current trend, so in in these days, the mostly the research are going on in this direction. Okay, so because we know that this is totally related to the human, or so if something wrong happened, then person may die. Okay, so we have to also see that thing. So that's why the validation is the we can say the problematic thing here. So you cannot use directly. There should be some maybe some involvement of humans as well. You cannot totally rely on the machine. That is the main stuff. You can take the help from the machine, but humans should be there. So if something wrong is happening, then uh, he can stop that particular thing. So you can use, like it can be used, but the validation is the problematic stuff, and uh, at least for now we cannot totally rely on the CNN stuff. But in the future, this type of things will happen. It will happen. So in the future, maybe we'll be using totally automated system where there will no involvement of the humans. So your robot will do all the stuffs using CNN, using deep learning stuff, or maybe we don't know. Maybe we could be having some different technology also at that time. Maybe quantum based deep learning. So we don't know what will happen in the future. But at least for now, we cannot totally rely on the deep learning. We have to somehow use the take the help from the humans as well.
Good evening, sir. I have one question. My name is Rahat Nas.
Hmm.
Sir, my question is how can deep learning models be optimized to improve the real-time image segmentation like accuracy, efficiency in low
Mm,
power devices like smartphones because currently we are switching to the mobile phones and other devices.
mm. How can this be optimized in what
Sir,
sense?
how can deep learning models can be optimized to improve the
Which
real-time image segmentation in this mobile phones and like smartphones?
No, it's doing. I think in many mobile phone, it is being used. Not very advanced deep learning technique, but at least they have incorporated some of the basic machine or deep learning techniques there. Because if you see, suppose if you are using your camera, you can
Yes,
also you can see that your face is coming and it's also giving the score of that, like what is
yes.
the score of that particular face. So that is like again one type of model is being used. So that's why you are getting that type of information. So deep learning is being
Sir,
used.
how about the if we are working for some real-time a bigger picture of the scenario in that moment of time, how these things can be optimized?
Uh, what type of scenario? Real time.
Hmm.
Your voice was not coming in between. Your voice was breaking. What was
Sir,
the
am I audible? I'm talking about some
no?
if I'm talking about some brain region and other medical image segmentation.
Hmm.
In,
Hmm.
in that case, how we can even utilize our smartphone
Oh, for the brain, for the medical imaging thing.
for medical imaging? Yeah.
Yes. So in medical imaging stuff, there is a issue. You cannot use always smartphone or because suppose if you are working in MRI, so there is no smartphone for that. Okay, because MRI is yes. So it depends. So some of the things can be captured using your smartphone. For example, pulse rate or few.
Yeah.
There are few things which can be captured using a mobile phone, and then you can use deep learning algorithm. Okay. But all the things you cannot capture using mobile because that is not possible. At least
That
for
is
now,
we
it's not
can't
possible.
do. But the point is that, sir, can we optimize our technique so that we in future we can come up with some solution?
There is solution. Like people are using model. People are using lightweight model, which can be
Mm.
run on the mobile phone.
Yes. Yes.
So, but for that again, you have to train the model because you have to. The first task is you have to train. Your model should learn the task. Okay. So first you have to train the model. So once you are done, you can use that model for your. You can just put that model on your mobile phone. But you know that mobile phone cannot. It will only take the lightweight model because
Yeah.
it is not having too much memory. So
Yeah.
you have to somehow make your model lightweight, and then you can put on your mobile phone, and then you can just use for the particular task.
Okay. Okay, sir. Thank you for the answer.
Yeah. Thank you. Any other question, or otherwise I will just stop.